Chen, what's the first thing we need to do to find the inverse algebraically? Tell me what's right. What do you do next?
Then you switch x and y.
Arrows and circles, super helpful. Keep going, Chen.
Then it'd be x equals y minus 2 over 6.
Thank you. Jesse A? Say that again. We're trying to get this y by itself. Did I show you guys my PEMDAS trick? I guess it doesn't work with this case, huh? It can still work. Because normally I would tell you go from bottom to top, right? Because you're trying to solve, but then there's no adding and subtracting, so I'm trying to make my system work. Y over 6 minus 2 6. Okay, Jesse, now if you're using PEMDAS going backwards, what would you do next? What does the A and S stand for? So you're going to add what? 2 6. Jesse, what's left? So we're adding those, right? So you can't put them together. And what's left on the other side? Pablo, what do we do next? We're trying to solve for y. Multiply by 6 on both sides. So we adding and subtracting, now multiplying and dividing. Look at this. The whole left side times 6, the whole right side times 6. Pablo, what's left? So on this side, what do you notice about those 6s? Yeah, canceling in this case equals 1. So we're just left with the y. Pablo, go ahead and distribute. How do you make 6 a fraction? You just multiply the tops and multiply the bottoms. Multiply the top, 6 times 2. Multiply the bottoms. And just simplify that. So now I have the inverse of x is equal to 6x plus 2. Question?
I just did like the over x direction, so I just made 6x minus equals y minus 2. That's what it needs to be.
What did you do?
I didn't do the addition and subtraction first because this is division, so I put
Just multiply by 6. Yeah. Raise your hand if you just multiply by 6 on both sides. Did we get the same answer?
Yeah.
Isn't math so wonderful? So you see division. Another way of doing the problem is just multiplying both sides by 6. Okay, watch this. I want to show you guys some magic. I'm going to just do this really fast, okay? Let's just say I told you to take the inverse of this. You would do y equals 6x plus 2. And then you would switch them, so you get x equals 6y plus 2. And then you would subtract 2. You don't have to copy this down. Just watch. And then you would divide by 6. You get x minus 2 over 6. Isn't that the original answer? So essentially the inverse, you're just working kind of inversely, backwards. I don't hear any crickets. Okay. It's another observation. Let's look at our calculators. Let's graph that. So into the first function, I'm going to put in x minus 2 over 6. Calculator command you can use is alpha y equals. What are you pressing?
Alpha y equals.
This gives you the n divided by d. Numerator divided by the denominator. So I'm going to type in x minus 2. Common mistake is putting a negative 2 there. And then I have the 6. That's just the original function, right? And then on the second function, y2, I'm going to put in the inverse, 6x plus 2. And then in the third one, I'm going to put in y equals x. That is the reflection line. And now I'm going to press zoom 6. Here is the original. There is our inverse, and that is the reflection line. So, how can you use the graph to check your answer? You do it algebraically, and then you can graph these two and realize that it should reflect over that line. Let's see if I can do that. Kind of. Maybe up here. Does that kind of make sense, though? What's happening? It gives you at least an idea, okay, like I should be directly over that point.